Welcome, students, to a curiosity show that will spark your interest with simple curiosity inside your house. I'm your resident curiosity teacher now, and we will learn about physics. For today, I will lead you to another discussion about thermal expansion. E. Volumetric expansion. The volumetric expansion is very similar with linear expansion. The material expands and takes up more space as it gets hotter due to the increase of kinetic energy of its molecules, causing them to move further apart. Here in this concept, we use three-dimensional object to show the volumetric expansion. Similarly with linear expansion, temperature change causes a change in the original volume of any solids and liquids, and we express it in cubic meters. It is approximately proportional to the change in volume and change in temperature, which is equal to degrees Celsius. The quantity beta is the coefficient for volumetric expansion, and it is expressed in degrees Celsius raised to -1. For solids, beta coefficient is approximately 3 times the alpha coefficient. A classic example of volumetric expansion is when you open a tightly sealed jar with a metal lid by running hot water over it. The metal lid expands more than a glass jar due to its higher coefficient of thermal expansion, making it easier to loosen and open the jar. When you pour hot water on the jar, the metal lid and the glass jar both experience an increase in temperature, causing them to expand in volume. We can express the volumetric expansion in this formula. Change in volume is equal to beta coefficient, which is expressed in degrees Celsius raised to -1, times the original volume, which is equal to the cubic meter, times the change in temperature, which we can express in degrees Celsius. Let's test our learning by solving a sample problem. Here is the sample problem. The outer diameter of a glass jar and the inner diameter of the iron lid are both 2.27 cubic meters at room temperature of 20 degrees Celsius. What will be the size of the difference in these diameters if the iron lid is briefly held under hot water until its temperature rises to 50 degrees Celsius without changing the temperature of the glass? The alpha coefficient given to us is equal to 1.2 times 10 raised to -5 degrees Celsius raised to -1. So what we do first is to write all the given in the problem. The original volume is equal to 2.27 cubic meter. The initial temperature is equal to 20 degrees Celsius, and the final temperature is equal to 50 degrees Celsius. In the problem, alpha coefficient is given to us instead of beta coefficient. So alpha coefficient is equal to 1.2 times 10 raised to -5 degrees Celsius raised to -1. So using the formula of volumetric expansion, change in volume is equal to beta coefficient times the original volume times the change in temperature. We are able to find the differences in the volume of the iron beam. So what we do next is to substitute all the given numbers to our formula. So change in volume is equal to 1.2 times 10 raised to -5 degrees Celsius raised to -1 multiplied to 2.27 cubic meter times the difference between 50 and 20 degrees Celsius. As I said earlier, beta coefficient is approximately 3 times the alpha coefficient. So the alpha coefficient 1.2 times 10 raised to -5, we are going to multiply it by 3 in order to find the approximate beta coefficient. So change in volume is equal to 3.6 times 10 raised to -5 degrees Celsius raised to -1 multiplied to 2.27 cubic meter, and the difference between 50 minus 20 degrees Celsius, 30 degrees Celsius. So what we are gonna do next is to cancel out degrees Celsius. and we are left a cubic meter. Next is to put all our inputs in our calculator in order to find the answer. So 3.6 times 10 raised to negative 5 times 2.27 times 30. So our answer is 0.0024 cubic meter. So in our problem, we are able to find the answer using volumetric expansion. The difference in volume in iron bead is equal to 0.0024 cubic meter. Now, let's check your understanding. I hope you learned something today and best of luck to your studies. Goodbye!